Welcome to my presentation. In this presentation, let us try to see how to find the determinant of a matrix, and then this time we will use properties of determinants to do that. And let us say we have an example of this type. Matrix A has elements of this type: -1, 2, 1, 1, 0, 1 in the second row, and in the third row we have 0, 1, 0. And matrix B, let us say we have elements of matrix B as follows: -1, 0, 0, and then 0, 2, 0, and then 0, 0, 3. Okay, so matrix A and matrix B are 3 by 3 matrix, and we want to prove the first property of determinants. Prove that determinant of AB is the same as determinant of A times determinant of B, like that. Okay, so let us take the first hand side, that is, we will try to find the product of matrix A times B, then find the determinant of that, and then we'll go find the right hand side. And if those two numbers are the same, then we have proved this particular example problem. So let's get started. Step number 1. In here we want to find the product of AB. The product of AB is, I'm going to write these, we want to find matrix AB like that. Let me write this. B a little bit more clear is going to be 1, -2, 1, and then 0, no, this is 1 here, this is 1, 0, 1, and then 0, 1, 0 times this matrix B here, -1, 0, 0, and then 0, 2, 0, and then 0, 0, 3. Okay, we want to find the product of that. And then how do we do that? This is the way we want to do it. So we're going to take the first row of the first matrix and then multiply that to the first column of the second matrix, and then the second column of the second matrix, and then the third column of the second matrix, and then write it out in the product matrix like this. So -1 times -1 times -1 is -1. I'm going to write the product directly, since we know how to multiply and put the numbers together. This is the way it's going to happen. 1 times -1 is -1. -2 times 0 is 0, and then 1 times 0 is 0. So we got the first element of the product matrix. Then -1 times 0 is 0, -2 times 2 is -4, and then 1 times 0 is 0, right? And then then the third element of the product matrix is going to be 1 times 0 is 0, plus 1 times 0 is -2 times 0 is 0, plus 1 times 3 is 3. We got the first row of the product matrix. Then we do the same thing for the second row. We take the second row and multiply to the second row of the first matrix and multiply to the first column, second column, third column of the second matrix, like this. 1 times -1 is -1, 0 times 0 is 0, and then 1 times 0 is 0. And then second column, 1 times 0 is 0, plus 0 times 2 is 0, plus 1 times 0 is 0. And then multiply that by the third column. 1 times 0 is 0, 0 times 0 is 0, and then 1 times 3 is 3. So we got the second row elements done. Then we go to the third row of the first matrix and then multiply that by the first column, second column, and third column of the second matrix. The way to do that is as follows: 0 times -1 is 0, 1 plus 1 times 0 is 0, and then plus 0 times 0 is 0. Then the second row multiplication will be as follows: 0 times 0 is 0, then 1 times 2 is 2, and then 0 times 0 is 0, and then 0 times 0 is 0, 1 times 0 is 0, and then 0 times 3 is 0. So we got all the elements of the product matrix. It is just a matter of simplifying this some more. So this is going to be negative 1 plus 0 will be negative 1, then negative 4, then 3. That is the first row of the product matrix simplified. Second row is negative 1, 0, and 3. And in the third row we have 0, 2, and 0. So this is our product matrix. This is our product matrix. And we want to now find the determinant of this matrix. The way to do that is as follows. The way to find the determinant is as follows. Let me write that here one more time, and we can do it this way too. So let me do it this way. We want to travel along the first row. We're going to travel along the first row, and then we will pick every element in the first row and write the minors of that. That is how we can find the determinant. And therefore, to do that, we're going to write that as follows. Determinant of AB is going to be equal to, since we're traveling along the first row, the first element will have the sign positive. If for the second element, it will have the sign negative. For the third element, it will have the sign positive. So we'll make sure that we are using the correct sign convention as well. So therefore, so let us start to do that. And before we do that, we want to make sure that we are on the right path here. Yeah, we are on the right path here. Looking at this example here, we wanted to change. We had a negative 1 for matrix A. Let's go and then change that. I want to put that in this color here, negative 1. So therefore, negative 1 times negative 1, this was going to be a positive 1. This will be a positive 1. So now we are on the right path. So let's keep going. So now we want to, if we travel along the first row, we take the first element of the first row and then write the minors of that, and then we'll proceed in that manner. And the way to do that is as follows. 1, the minor of that is going to be, we're going to not consider the elements along the row, not consider the row elements along the first column. So whatever is left with, those are going to be the minors of that element. So the minors of element 1 are going to be 0, 3, 2, and 0. Since we have the sign convention, we need to use that sign convention there. And then in here again, this should be a positive 2, not a negative 2. So 2 times 2 is going to be a positive 4. This is going to be a positive 4. And now we want to pick the second element, and then the second element here is going to be, it is a positive 4. Since the sign convention is negative, so we're going to pick the negative 4 like that. And then the minor of that is going to be negative 1, 3, 0, and 0, like that. And then the next one is, we're going to go to the first row, first row, third column element, which is 3. The sign is positive, so therefore the minor of that element is going to be negative 1, 0, 0, and 2, like that. And now if we were to expand this is what we're going to get. So this is going to be 1 times 0 is 0, 2 times 3 is 6 with a negative sign, minus 4 times negative 1 times 0 is 0, minus 0 times 3 is 0, plus 3 times 1 times negative 1 times 2 is negative 2, and 0 times 0 is 0. And therefore, what we have here is 1 times negative 6 is negative 6, 4 times 0 is 0, and then 3 times negative 2 is negative 6. Therefore, when we simplify this, this comes out as negative 12. We'll keep that value, and then that is the product of, that is the determinant of AB, like that. Now we need to prove the right hand side and see if we get to the same value. To do that, we want to find the determinant of matrix A, which is going to be negative 1, 2, 1. These are the elements of matrix A, and then 1, 0, 1, and then 0, 1, 0. These are the elements of matrix A. And to find the determinant of this, the way we want to do this is as follows. We're going to again travel along the first row, and then the first row, first column, we pick the first row, first column element, write the minors of that, pick the first row, second column element, and then pick the minors of that, and then pick the first row, third column element, and then pick the minors of that. And the way to do that is as follows. We're going to write this one as negative 1. Again, here, this is positive, this is negative, this is positive. That is the sign convention we're going to follow. So negative 1, the minor of that is going to be 0, 1, 1, 0. And then negative 2, the minor of that is going to be 1, 1, 0, 0. And then plus 1 times the minor of that is going to be 1, 0, 0, 1, like that. And therefore, when we expand this, this is going to be negative 1 times 0 minus 1 minus 2 times 1 times 0 is 0, 0 times 1 is 0, and then plus 1 times 1 is 1, 0 times 0 is 0. So when we simplify this, we're going to get negative 1 times negative 1 is positive 1, 2 times 0 is 0, and then 1 times 1 is a 1. Therefore, the determinant of matrix A is, the value of that is equal to 1 plus 1 is 2. So we'll keep that. We'll do the same thing for matrix B. And then find the determinant of that, and then see what value we get for the product. So the determinant of matrix B has the following elements. We're going to pick the elements of the matrix which are negative 1, 0, 0, 0, 2, 0, and then 0, 0, 3. These are the elements of the matrix. And to find the determinant, again, we will travel along the first row. We can travel along any row, or we can travel along any column, as we have shown you in my previous video presentation. No matter which way we travel along the rows or along the columns, the determinant is going to be the same. So for convenience, we are traveling along the first row in this particular example problem. So to expand this, we can write this one out as follows. We're going to write this as negative 1, the minor of that, which is 2, 0, 0, 3, and then again here I want to specify that the sign convention here is positive for that, negative for that, positive for that. That is the sign convention we want to follow. And therefore, since we have a negative sign for the element, positive times negative will be a negative. Therefore, negative 1 and the minor of that, minus 0 times the minor of that, 0, 0, 0, 3, and then plus 0 times 0, 2, 0, 0. Here I just wanted to write it out and show you, but as you can see, 0 times the minor is going to go to 0, 0 times the minor is going to go to 0, so we can discard that information. All we need to do now is just expand this part of it. Negative 1 times 2 times 3 is 6, 0 times 0 is 0, and then plus 0, we can discard those zeros anyway. So negative 1 times 6 is negative 6. So therefore the determinant of B, matrix B, came out as negative 6. Now we'll put everything together. So the determinant of A times the determinant of B is going to be 2 times negative 6, which is going to be equal to negative 12, and that is exactly what we had to start with. If you go back here, determinant of AB was equal to negative 12, and therefore we have proved this first property one more time, saying that the determinant of AB is equal to determinant of A times the determinant of B. The determinant of AB, we showed that it was equal to negative 12, and the determinant of A was 2, and the determinant of B was negative 6, and therefore when we multiply this out, 2 times negative 6 is negative 12. Therefore the left hand side is exactly equal to the right hand side, and therefore we have proved that by taking any example we can prove the property of determinants to be true. In my next presentation we shall look at some more examples and see how we can apply these properties of determinants to solve them.